Alright, here are the solutions for the Newton's three-law worksheet. The first question reads, as the mass of an object on Earth's surface decreases, what happens to the inertia and the weight of the object? Well, using Newton's second law of F equals ma, we see that the mass is directly proportional to the force, or its weight. So if the mass is decreasing, that means the weight has to also be decreasing. In terms of inertia, we know that Newton's first law could be called the law of inertia, which means that an object is going to have a tendency to resist motion, and that resistance is called the inertia. That is directly proportional to the mass also. So if the mass is decreasing, the inertia will also be decreasing. Looking at our choices, we see that choice number 1 is the correct answer. The inertia decreases and the weight decreases when the mass of an object decreases. The second question reads, compared to the inertia of a 0.1 kilogram steel ball, the inertia of a 0.2 kilogram styrofoam ball is. Well, we said that the inertia and the mass are directly proportional. So if the mass of one equals 0.1 kilograms and the mass of the second object equals 0.2 kilograms, we see that the mass was doubled. If the mass is doubled, that means that the inertia has to also be doubled. So the answer is choice number 2. The next question reads, a ball rolls through a hollow semicircular tube lying flat on a horizontal tabletop. On the following diagram, draw a line with an arrowhead to represent the path of the ball after emerging from the tube as viewed from above. Well, if the object goes into the tube in that direction, it must come out of the tube along the same horizontal vector but in the opposite direction. While in the semicircular tube, it's going to want to continue to move this way. The tube is going to orient the ball in the opposite direction. Next question. The following graph shows the relationship between the acceleration of an object and the net force of the object. What is the mass of the object? Well, we have mass, we have force, and we have acceleration. So Newton's second law says force equals ma. We can see that the horizontal axis is the force, so we'll take an arbitrary x point, which is 1 Newton, and we'll set it equal to a y coordinate, which is 2 meters per second squared. When we divide by 2 and we divide by 2, we see that the mass has to equal a half a kilogram. When we look at our choices, we see that choice 3 has to be the correct answer. Alright, question number 59 reads, a car is uniformly accelerating from rest. The net force acting on the car is, well, according to Newton's second law, F equals ma. If the acceleration is uniform, we'll highlight uniform, which means it's constant. The force has to also be constant. So when we look at our choices, the only choice that has a constant net force acting on the car is 3, constant but not 0. But why not 0? Well, the only way the force can be 0 is if the acceleration is 0. And since we know that the acceleration is uniformly accelerating, we know that this cannot be true. Therefore, choice number 3 makes sense. Constant, but not 0. Alright, question 60 reads, an 8 kilogram block and a 2 kilogram block rests on a horizontal frictionless surface. When horizontal force F is applied to the 8 kilogram block, it accelerates at 5 meters per second squared east. If the same force was applied to the 2 kilogram block, the magnitude of the block's acceleration would be. Well, for this problem, we need to use F equals ma twice. We have to use F equals ma using the first block, and then F equals ma for the second block. The first F equals ma equation, we can input that the 8 kilogram block is accelerating 5 meters per second. This will produce a force of 40 newtons. Since we're going to take that 40 Newton force and we are going to let that force act upon the 2 kilogram block, we need to find out what the acceleration would be. when we divide 2 and we divide 2, we see that the acceleration would be 20 meters per second squared. When we look at our choices, we see that the choice number 4 is the answer. Alright, the next question reads, a 6 Newton force and 8 Newton force act concurrently on a box located on a frictionless horizontal surface. Which top view diagram shows the forces producing the smallest magnitude of acceleration of the box? Well, the smallest force will produce the smallest acceleration, since force is directly proportional to acceleration. Therefore, when we look at these choices, we want to have the resultant of we want to find the smallest resultant. Out of the choices, we see that choice number 4 will produce the smallest resultant, since the degree between the two force vectors is 180 degrees. We know that that will produce the min resultant. To show you, if we have a force of 8 newtons going in this direction and a force of 6 newtons going in this direction, it would produce a small force like that of 2 newtons going in the right direction. Therefore, choice number 4 is the correct answer. Alright, the next question. As the vector sum of all the forces acting on a moving object increases, the magnitude of the acceleration of the object does what? Well, again, if force equals ma and the forces increase, what happens to the acceleration? Well, acceleration is directly proportional to force, which means the acceleration needs to increase. Therefore, the correct answer is number 2. And finally, the last question on this page reads, an unbalanced force of 10 newtons north acts on a 20 kilogram mass for 5 seconds. Calculate the acceleration of the mass. This is an easy F equals ma problem, where F equals 10 and m equals 20. Therefore, A equals a half a kilo. Oh, I'm sorry. A equals 1/2 meters per second squared. Alright, and finally, the last question on this page reads, an unbalanced force of 10 newtons north acts on a 20 kilogram mass for 5 seconds. Calculate the acceleration of the mass. Well, this is a straightforward F equals ma problem. F equals ma problem, where F equals 10 and m equals 20. Therefore, the A is 10 divided by 20, or a half of meter. Meter per second squared. Alright, question number 64 reads, two horizontal forces are applied to a 2 kilogram block on a frictionless horizontal surface, as shown in the following diagram. The acceleration of the block is, well, when we're talking about mass and acceleration and forces, we need to use the equation F equals ma. Since we know F stands for the net force, or all the forces acting on the object, we know that there's two forces acting on this object. So we have an 8 Newton force minus a 2 Newton force, since it's happening in the opposite direction. The mass is 2 kilograms, and we are finding the acceleration. The equation becomes 6 equals 2a. We divide by 2, a equals 3 meters per second squared. We look at our choices, we see that there's two possibilities. We have 2 meters per second squared in the right direction and 2 meters per second squared in the left direction. When we look at our original force vectors, we see that the one force vector is going to the left, which is 2 newtons, and one force vector is going to the right, 8 newtons. So we know that the stronger force is going to the right, therefore the object will travel to the right and also accelerate to the right. So the correct answer is choice number 3. When we look at the next question, which graph best represents the motion of an object on which the net force is 0? Well, we know when the force is 0, the acceleration has to be 0. That means that the object must be either at rest or moving with a constant velocity. When we look at our choices, we see only one graph which represents constant velocity. That is choice number 1. Choice number 1 it produces a linear graph and represents the distance traveled over a time interval. Since it's a straight line, the slope tells us that the object is moving with a constant velocity. In all the other options, each graph represents an increase or decrease in speed. Since there's an increase or decrease in speed, that means that there's an acceleration. Since there's an acceleration, that means a force must be applied to the object. Therefore, choice 1 is the only answer that makes sense for this question. Question 66 reads, the vector diagram below represents force F acting on point P. Which vector diagram represents the pair of concurrent forces that would produce equilibrium when added to force F? Well, if we have force F, we know in order to satisfy equilibrium, there needs to be another force going in the opposite direction. I'll label it R. When we look at our choices, there's only one choice that could produce a resultant force in that direction. That is choice 4. When using the head-to-tail method, we connect the tail to the head. We connect the tail of one vector to the head of the other. And we produce the resultant by going from the original tail to the second vector's head. This will be the resultant. Matching it up with the force vector, which we need to produce equilibrium, we see that choice number 4 is the only option that would produce that resulting force. Question number 67 is similar to question number 65. Which graph best represents the motion of an object that has no unbalanced force acting on it? We know that the object must be traveling with a constant velocity. Therefore, the only graph that depicts this is choice number 4, where the displacement and time is producing a linear function with a slope which shows us constant velocity. Question 68 says, 4 forces act on an object as shown in the following diagram. If the object is moving with a constant velocity, what is the magnitude of force F? Well, when an object moves at constant velocity, we say that the object is in equilibrium. All forces acting on that object has to equal 0. So force net must equal 0. In this example, we see 2 forces in the y direction and 2 forces in the x direction. So when we look at the force in the y direction, we see a 30 Newton force up minus a 30 Newton force down, which equals 0 newtons. When we look at the force in the x direction, we see a 40 Newton force to the left minus F. Therefore, we know in order to produce a 0 Newton net, F must equal 40 newtons in the right direction. Alright, question number 69 reads, a 1 kilogram book rests on a horizontal tabletop. The magnitude of the force of the tabletop on the book is? Well, if we draw the figure of a book on a tabletop, we know that the book is applying a force downward of 9.8 newtons. According to Newton's third law, where every action has an equal and opposite reaction, the tabletop has to be producing a force going in the opposite direction of 9.8 newtons. If we look at our choices, we see that choice number 4 makes sense. That the magnitude of the force of the tabletop on the book has to be 9.8 newtons.